In this video, we will discuss percent composition. Percent composition tells you the percent by mass of each element present in a compound. If you look at your reference table, the equation for percent composition is on the back, table T, just like all the equations we need for the year. It says percent by mass equals mass of the part over mass of the whole times 100. So sometimes the question will straight out ask what is the percent composition. Sometimes the question says what is the percent by mass. In either case, whether they say percent composition or percent by mass, you're taking the part of the element that they specify in the question divided by the whole. This is just the gram formula mass. And then you're going to multiply your answer by 100. Don't forget that times 100 piece. That's really important. Sometimes on the regions, students will forget that times 100 piece, and then you can't get credit for the answer. So make sure that you don't forget that. So here's a typical question. What is the percent by mass of hydrogen in NH3, ammonia? So every time we see a question, we always want to annotate our question or underline anything that's important. So here it says percent by mass. I go to the back of the reference table and we see our equation is percent by mass equals mass of part over the mass of the whole times 100. So what is the part they're looking for? The part will always be whatever is coming after the word of. So in this case, hydrogen. So we find the mass of hydrogen. Hydrogen weighs 1, and there are 3 of them. So we have to do 1 times 3 over the whole thing, which would be the gram formula mass of ammonia, NH3. So 14 for the N plus 3 for the H. So we have 3 over 17 times 100. And we get 17.6%. So we do 3 divided by 17 times 100. We did 3, not 1, because there are 3 hydrogens in ammonia. The next question is asking us what's the percent by mass of oxygen in Fe2O3. So again, we're going to underline anything that's going to help us as we're reading this question. It says percent by mass. When we see what is the percent by mass, we flip to the back of the reference table and we see we have to use our percent composition equation. So percent by mass equals the mass of the part over the mass of the whole times 100. Okay, the part they're looking for will always be after the word of. So we are looking for the part of oxygen. There are 3 oxygens, so we have to multiply the mass of oxygen by 3. So we will have 3 times 16 over the mass of the entire compound, which would be 3 times 16 plus the 2 irons. So 2 times the mass of iron is 56. So we end up with 48 over, after adding all the math together, for Fe2O3, 160, and then you multiply by 100. After doing the math, we get that this is 30%. Okay, the next question is asking us what's the percent by mass of water in BaCl2.2H2O. We already talked about in class that this dot indicates what we call a hydrate, which just means we have this crystal with water molecules attached to it. Again, as we're annotating our text, it says percent by mass. That's how I know I have to use my percent composition equation. So percent by mass equals the mass of the part over the mass of the whole times 100. I told you that the mass of the part will always be after the word of. So here's the word of and then water. So this question is a little bit different than the ones we've done before, and that it's not asking for one particular element, but it's asking for what is the percent by mass of all the water in this hydrate. So if you notice, there are 2 water molecules in this hydrate. as evidenced by that coefficient 2. So the percent by mass is going to be equal to the mass of all the waters. We could show you over here, water is, the gram formula mass would be 18. Remember, H is 1 times 2 is 2. Oxygen, there's 1 oxygen times the mass of oxygen is 16. So when you add 16 and 2, we get 18. Now we have 2 water molecules, so we're going to multiply the mass of the water by 2 to find the percent of all the water in this compound. We would then add that to the mass of the barium chloride. And when we do that, the gram formula mass will be 243. So we have the mass of the water is 36 over the gram formula mass of the entire compound is 243. Then we multiply by 100. And we end up with 14%. I would probably say 14.8% actually, or we're closer to 15%. The last thing we want to talk about today are hydrates and determining percent composition of a hydrate. So a hydrate, remember we talked about in class, would be where you have some type of crystal molecule, let's say copper 2 sulfate, and it has this dot and the water molecule is attached. So in some cases we may want to figure out what's the percent composition of the water, in which case you could just do the mass of the water over the whole thing. It's useful to be able to remove the water. So for example, let's say you were given a problem and it said the mass of the crucible and cover was 11.70 grams. The mass of the crucible and cover and the hydrated, which means with the water, crystal, was 14.90. And the mass of the crucible and cover and hydrosalt after heating was 14.53 grams. And they wanted you to figure out what's the percent by mass of water. So let's just talk about this word anhydrous. Anhydrous means without the water. So after you heat it up and the water is removed. So if you notice in this question, they want us to figure out the percent by mass of the water, but they don't tell us how much the water weighs. So to figure out the mass of the water, what we would have to do is take the mass of the crucible, the crystal with the water, the hydrated crystal, and subtract from it the one where there is no water. So if we do that, 14.53 subtracted from 14.90, we get that the mass of the water would be 0.37 grams divided by the mass of the whole thing, which would be 3.2 grams, and then multiply by 100. I know the sample only weighs 3.2 grams because we could subtract the mass of the crucible out from the crucible and cover and hydrated crystal to figure out what the mass of just the original compound was. We will look at more examples in class tomorrow.